Okay, so today I'm going to talk about ions. Since what we're building up to is the ionic bonding model, I figure now's a good time to talk about ions and what ions are. So I said that before, back in chapter 3, we said that the number of protons defines a given atom as an atom of that particular element. So this is not really the case for electrons. Electrons aren't, the number of electrons are not what dictates the element that an atom is. It's the number of protons only. So up until now we've said that the number of protons and electrons are equal, but that's specifically for neutral elements. So if you look in the periodic table, aluminum has atomic number 13, which means it has 13 protons, right? But that means it has, we've said until now, it means it has 13 electrons, because otherwise it would not be neutral. That's the only way it can have no charge. So what can happen, though, is electrons can be gained or lost during a chemical reaction, right? So this actually can, this is how we get ionic bonding. So if electrons are gained or lost, then the number of protons and electrons wouldn't be equal anymore. So imagine we have aluminum, right, with its 13 protons, and it's normally 13, and I wrote neutrons for some reason, 13 electrons, right? So imagine that aluminum lost 2 of the electrons, right? So now it only has 11, right? Well, now it's no longer neutral. Aluminum is no longer neutral. The charge is going to be equal to, why I did that, there we go. The charge is going to be equal to the, so I'll just rewrite that, I guess. The charge will be equal to the number of protons minus electrons. Since protons constitute a positive charge and the electrons constitute negative charge, we would have 13 minus 11, so that's positive 2, right? So there's 2 more positive things in this aluminum atom than there are negative things. Now, if that were the case, if the charge is positive 2, then we indicate that up here in the upper right-hand corner. That's how we indicate charge. So this aluminum atom, actually there's a different word for it, this aluminum ion is positively charged. So an ion is an atom or a group of atoms that is electrically charged due to the gain or loss of electrons. So you should realize that we don't call it an atom if it has a charge. If it has a charge, it's called an ion, even if it has multiple atoms in it. You can have polyatomic ions, but a molecule has to be neutral. So like later we'll see things like SO4 2-. This is not a molecule, this is an ion. Anything that has a charge is an ion. And in fact, there's 2 kinds of ions: cations and anions. All these mean, cation just means positive ion, positively charged ion. An anion is a negatively charged ion. So you may have trouble remembering cation, anion. Really, it's just the prefixes meaning positive and negative, like cathode, anode. But if you have trouble remembering it, I'm going to embarrass myself with a really silly mnemonic, which is cats have paws, so cations are positively charged. It's kind of silly, but that might help you remember it. So here's the charge, number of protons minus number of electrons. So if an atom loses electrons, it becomes positively charged. I know this can be counterintuitive, but you have to remember that electrons are negatively charged. So losing electrons makes it positively charged, and gaining electrons makes it negatively charged. So remember, I talked about metals and nonmetals. Metals tend to lose electrons and become cations. So metals tend to be cations, and nonmetals tend to be anions because they gain electrons, right? So if something loses 2 electrons, it gains a +2 charge. If it gains 2 electrons, it gains a -2 charge. Okay, so as I said before, the charge, both the sign and the magnitude, are indicated in the upper right-hand corner of the symbol. So this can be included with the mass number indicating what isotope it is, or we could just be saying it's any old potassium atom, we don't care which isotope it is. An oxygen atom that has gained 2 electrons, what charge would that oxygen atom have if it gained 2 electrons? That's right, it would be -2. Remember, electrons are negatively charged, so taking on 2 extra electrons gives it a -2 charge. So we put that 2- up there in the upper right-hand corner. Now, it should be noted that when electrons are gained or lost, the properties of the atom change completely. They're very, very different. So here's a good example. Consider sodium and chlorine. Sodium is a poisonous metal that reacts explosively with water. Chlorine is a deadly gas that's actually been used as chemical warfare. Sodium will lose 1 electron to chlorine. So sodium loses an electron, chlorine gains an electron. So what charge does sodium get? Hopefully you're thinking it's +1 because it loses 1 electron. Chlorine gains that electron, takes it from sodium, and gets a -1 charge. So this is table salt. Table salt is sodium and chloride, or sodium and chlorine ions put together. Now, we can eat this. This is okay. It's not, neither of them are deadly in this form. The charges, the ions, behave completely differently than the parent atoms, than the neutral atoms. This also sort of answers a question that I get from students a lot. When they look on the periodic table, they see that calcium is a metal. And a lot of times people say, well, that doesn't really settle well with me. That doesn't make a lot of sense. Because calcium, right, is in bones, it's in milk, in chalk. I don't see that as a metal. If I brought you actual calcium, neutral, pure calcium, you would see that it is in fact definitely a metal. It's shiny, it's malleable, it tarnishes, it looks like a metal. The calcium in all the forms I mentioned just a moment ago, bones, milk, chalk, is calcium 2+. So the ions behave totally differently. So it's still considered a metal because of its behavior in the neutral state, but understand that its ions are not going to seem metallic, right? Iron rusts, it doesn't really look metallic anymore when it rusts, right? So once things become ions, they change their properties. Okay, so try this, and then I'll come back. So pause it and try this, and just determine the number of protons, neutrons, and electrons. Okay, so hopefully you're ready. Magnesium, we can look on the periodic table and see that it has 12 protons. Normally, that means you'd have, and if we want to know number of neutrons is easy. Neutrons just take 25 minus 12, and that's 13, right? And then, normally it would have 12 electrons, but that's not what's happening here. Magnesium has a +2 charge. Now, does that mean it gained 2 electrons or lost 2? Hopefully you said it lost 2, so now it has 10. Something that has a positive charge has to have lost electrons, right? Number of protons isn't changing, the number of electrons is. Okay? Iron, how many protons is that? That is, I have to look on the periodic table, 26 protons. Neutrons, I have to do some maths here. It's 32, because 58 minus 26 is 32. Electrons, If it was neutral, it would be 26, but it has lost 3 to be 23. Right? Sulfur. Sulfur has 16 protons because it's in block 16 of the periodic table. Neutrons, 30 minus 16 is going to be 14. And electrons, it has a negative 2 charge, meaning it has gained 2 electrons for 18. All right, so hopefully that all makes sense to you.